Okay, hopefully we've learned that if the equation is y equals e to the x, then the derivative is very nicely is also e to the x, which means the antiderivative of e to the x has to be also e to the x. Oh, of course, plus c, plus some constant. Okay, so this is, the derivative is actually really easy to get, and so we just got to learn how to derive these. And so here's some examples here. So if I look at y equals e to the 3x, then I got to remember to apply the chain rule and say the derivative of the outside would be e to the 3x, because the function is the same, times the derivative of the inside, so times 3. This would normally be rewritten as 3e to the 3x. Next problem involves the product rule. So I've got to do derivative of the first, 5x to the fourth, leave the second alone, plus now leave the first alone, times the derivative of the second, which is 2e to the 2x. And this could be simplified, but not important at the moment, just I'll make sure you can get the product rule down for that. Next one is the quotient rule problem. So the derivative of e to the x squared is e to the x squared times the derivative of the inside times 2x, leave the second one alone, minus, now leave the first one alone, e to the x squared times ln x all over the bottom one squared. So here's another one. I could derive this as natural log of e and say it's 1 over that something times the derivative of that something, or I can realize the natural log and e are going to cancel each other out, and so this equation is really x squared, and so the derivative is 2 to the x. So the key here is, remember, there's a natural log and e are inverse functions of one another. They undo one another, so I can actually simplify this equation and make this a lot easier derivative to come up with. This one, to derive this one, I've got an outside function. Derivative of cosine is negative sine e to the t times the derivative of that function means it's times e to the t again. Okay, next function is an antiquated notation. They don't use this much anymore, but just in case you see it, so it'll show up in your homework a little bit. This is the same as e to the sine x. And it's just a way to rewrite this, so you didn't have to use the raised notation for exponents. It was easier to write it in one line. So the derivative of this would be the derivative of e to any equation is itself times the derivative of that function, cosine x. And so here's some functions of how to derive e to the x. So let's try some antiderivatives. So remember, we've got to use the anti-chain rule. So the antiderivative of e to the 2x would be e to the 2x, but now we're going to divide by the derivative of the inside, which, remember, I'm going to multiply by 1/2 plus c. So again, the antiderivative of the outside function is easy. I just got to remember to follow the chain rule and divide by the derivative of the inside. So let's take a look at this problem here. This one's a little bit harder to see. I can see this looks like an inside function because that looks like my outside function. So I'm going to antiderive the outside, 1/5. Leave the inside of function alone to the 5th power. And then I'm going to divide by its derivative. So remember, I have to divide by, in this case, 3e to the 3x. Well, if you notice here, the e to the 3x divided by e to the 3x cancels, but the 1/3 does not. So I'd have to times it by 1/3, remember, to complete the dividing by 3. So again, I got to follow the anti-chain rule exactly. So if I look at this the next problem here, same principle here. I can antiderive this function and realize it's the same function. But then I have to divide by its derivative. Well, the derivative of sine is cosine x. And that's nice because that actually cancels out the rest of the equation. And so there's my answer, plus c. Here's that antiquated function again. Remember, this means e to the 5x. And the antiderivative of that is 1/5 e to the 5x, evaluated from 2 to 3. Then I plug in 3, so it would be e to the 15th. And I plug in 2, 1/5 e to the 10th. And that's a good enough answer. I can grab my calculator and see what that is. Next problem here is another function. If you notice, e and natural log are inverses of one another, so they cancel each other out. So I'm actually asked to find the antiderivative of x here, because this is equal to just x once that cancels. So the antiderivative of that is 1/2 x squared, evaluated from 3 to 4. And I plug in 4 and 3, and I get 1/2 of 16, so 8 minus 1/2 of 9, 4 1/2. And so this comes out to be 3.5 is my final answer. And so here's some practice with antidriving with e to the x.